Hi everyone, welcome to the next problem from Blind75, which is a seventh problem and it is called valid parenthesis. So let's look at the problem. Given a string S containing just the characters brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket at the same time. I think this is pretty obvious because we learn how to put the braces, uh, open brackets, etc. So so this is a valid one because there is an opening and there is a closing for the same type. This is also valid. This is not valid. How do we solve this problem? Let's take a look. So I have written some of the examples here. Uh, let's see how we can solve it. Okay. So we will use stack here to find the characters. So how do we do it? Let's run over a couple of examples to see how we can go about it. Okay, so this is stack. I'm just writing or drawing like this so that you know it is a stack instead of getting confused. So let's take this particular example. This is a opening close, so we add this. There is another brace here, so we add it. The next one is a closing bracket, one of it, right? Then what we do is we will check this with the top of the element. Is this a complementary of the current character, which is this? Yes, then we will pop it. Okay, so now the stack has become only with this brace. Let's go to the next one, which is again a opening one, so we add it. There is a closing one. We check the top of the stack, both are complementary, so we pop it. Then we look at the last one, so at that time the stack is just with this. Then we see if this and this are complementary. Yes, this is the closing bracket of the top element of the stack. Then we pop it. At the end we get an empty stack, so that means it's a valid brace. Okay, so let's take another example, maybe a faulty one or one which is not valid anymore. Let me write one. So we will add this, we'll add this, and we will we'll add this. This is a closing, then we'll add this, then the opening, then this. What would happen in this case? This is an opening brace, right? So we'll add it to the stack. The next one is also an opening brace, so this is opening. The next one is a closing one. Okay, we check that whether the top of this is complement. No, that means it is not a valid one, so this passes, right? So let's take another one. Okay, so what will happen in this case? The first one is opening, then again opening. The next one is closing, so we pop it. This is open, then we add. So there is nothing here, so we add the opening one. Then comes the closing, that means we pop it. Then comes the opening, we add it. Then comes the closing, we pop it from the stack. We remove it from the stack. but this is not a valid because of this additional bracket. That means there is no closing bracket here. If there was one like this, it would have passed, but there is nothing. So it is important that at the end of the iteration, the length of the stack should be 0 for this string or string S to be a valid parenthesis. Let's see how we can code this. So I'll define a stack. I'm going to add it to the dictionary so that it is easy. Complementary characters. So I'm adding the key as the closing bracket and the value as its opening braces. Okay, so here this is the key, and this is for us to be able to compare when we pop it. Okay, that means for the element, the current character, the top of the element should be this. If the current character is this, the top of the element should be this, top of the stack should be this, and so on. So let's yeah, so the okay, so this is the complementary character. So we'll iterate through for char in s. So we have to see whether a char can be anything other than this. So here in the constraint it is written that it is only one of these characters, not the other one, and it cannot be an empty because at least it would be at least one length, right? Yeah, so for each character in S, if character not in complementary character, that means it is a opening braces, any of the opening braces, okay, can be this or this or this. Okay, I'm just writing it as a comment here. So what do? We append it to the stack, right? Else time to pop. So now we need to compare the stack. What if the first element itself is a closing brace? For example, the string that is given to us is say this, like this. It would be the case, right? So we have to see if there is stack already. If there is nothing, that means this is valid, this is not valid at all. So let's write that. So if stack of -1 is a top element, not equal to complementary chars of char. So the current character is this, so we are fetching this particular value, whether to be the top element. If it is not equal, that means it is not a valid one, return false. If it is, then we will do pop. Okay, so we'll pop the last element. What if the stack itself is not there? It would be in this condition, right? Stack is initially empty. We are trying to check whether it has something like this on the top, but it is not, so it should be return false, right? So we will do return false. So once the iteration is done, what do? We will return len of stack. So it has to be 0, right? So is 0, so it will return true if it is 0, else return false. Let's try running the program. Yep, so yeah, that's it. So let's talk about the complexity, time complexity. So we are doing one iteration, so it is order of n. And what is the space complexity? Space complexity is maximum would be order of n, where n is the length of the string, right? Something like, for example, the worst case could be something like whether it has only the opening braces, like this, right? That is a worst case. So the maximum would be order of n. So it can go from somewhere by order of n, by it doesn't need to be. So so the maximum, the worst case is order of n in the space complexity. So let's try submitting it to see whether we are passing all the test cases or not. Yeah, so that's it, guys. This is the end of the this problem, which is valid parenthesis. It's an easy one, and I hope you understood this, and see you soon with another video from Blind75. Thanks for watching. If you like this video, please don't forget to like and subscribe. See you again in the next video. Thank you. Bye bye. Take care.